I am Dr. Ameer Hassan, head of neuroscience department at Valley Baptist, a professor of neurology and neurosurgery, and the CEO of Quantanosis.ai. And what happened was during COVID, I was president of SVIN at the time, and one of our biggest societal missions was mission thrombectomy. And the idea is to improve mechanical thrombectomy access, treatment for large vessel stroke all around the world. And as we're doing this project, it's costing millions of dollars. It needs a lot of volunteer power. And what we noticed was the biggest hurdle is infrastructure costs. You need to install biplane, you need to buy catheters, you need to have 2 physicians on call. So we were looking into more inexpensive ways of building thrombectomy access. So as I was looking through different technologies, using lasers or whatnot, my co-founder and I fell upon ultrasound. We started testing some theories. We did our first tests and we were like, eureka, you can treat stroke through the temporal windows. And with ultrasound, break up that clot and get better recanalization, better opening of the blood vessel than either IV thrombolytics or mechanical thrombectomy today. And it's safe. So in 2013, there were 3 negative trials on mechanical thrombectomy. And basically, we thought that's it. We're not going to treat stroke with catheters. It's only IV therapy alone. Then 2015, a bunch of positive trials came out. And one of the things in the negative trials was they didn't confirm whether or not the vessel was occluded. And they also used this ultrasound catheter. So I went back to one of the guys who worked on this project. And he was Dr. Kreshu, who's my mentor. And I was like, hey, what did you think of this device? He's like, oh, it was very stiff and it took a lot of effort to bring up. So I said, okay, what about if we could make it more trackable? And that was the original path I was taking, is to use a catheter like an ultrasound catheter that could be reused. So you wouldn't have to keep charging the patients, right? Hospitals could just charge like a set fee and reuse all the devices. Then I was stumbling on a bunch of roadblocks and hurdles and from a technology standpoint. And then my co-founder, who's my best friend for 18, 19 years, basically says, I don't understand, if it's ultrasound, why do you have to go inside the vessel? Why can't you just go outside? Isn't the whole idea of ultrasound is that you use a probe? And it was like a eureka moment. And I was like, you're right. Why do we need to use a catheter? And then we started changing the technology to focus on non-invasive ultrasound technology using histotripsy. So basically, we plan on all patients going into the emergency room and they would get confirmed to have a large vessel occlusion. Today's technology is CT angiogram, CT perfusion. Then typically you take the patient cath lab. What we're going to do then is you go back to the trauma bay or stroke bay in the emergency room. You would be intubated and paralyzed like you would for mechanical thrombectomy today. And then we're going to have these probes. And basically you're going to lay down flat, right? You're intubated, you're laying on this bed. And you have 2 probes, one ipsilateral, one contralateral. And using transcranial Doppler, we're using ultrasound technology to find the location of the clot. Then we hit it with histotripsy. It's all automated. Like it finds the clot, it'll treat the clot. You just push a button to activate. And then it treats the clot and breaks it up into pieces that are 250 microns or less, which is much better than IV TPA today, tenectoplase, or mechanical thrombectomy. So our goal is about 70% of patients will be treated with this device. And you'll probably get, TICI 2B3, which is our version of like recanalization scoring, 70% of the time with very low hemorrhage rates. So why wouldn't you want to do this? It's non-invasive, low risk, it's all automated. And the idea is then you can grow from comprehensive stroke centers to primary stroke centers. There's like 250 comprehensive stroke centers in the US. There are 2,500 primary stroke centers. So 10 times more hospitals treat stroke with just IV therapy. Only 10% of those hospitals treat with catheters. So if I can provide this solution to all hospitals in the US, you're saving time, decreasing the length of stay, probably getting much better outcomes because patients who get treated faster, right? We always say time is brain. If you get treated faster, you're more likely to be completely, functional after your stroke. So about 800,000 strokes occur in the US, 17 million in the world. And of those, they say about 20% have large vessel occlusion, which is the type of disease we're trying to treat. We're not going to treat bleeding with this, right? It's specifically a middle cerebral artery occlusion. So of those today, somewhere between 3 and 7%, some literature says up to 10%, get treated with IV thrombolytics. That only works 30% of the time. In carotid terminus, it only works 6% of the time. So we have therapies, but they don't always work, right? Whether it's the IV and mechanical thrombectomy works 90% of the time, but usually you get to the center way too late. You get to a primary, then they transfer you. It takes 2-3 hours. Then they take you up to treat you. It's another hour later. So there's significant delays in treatment. And every 2-minute delay, 2 million neurons die. So there's significant effect on the brain if you keep the vessel closed. Now, from our standpoint, why we said 70% is because not all human skulls are the same. So some skulls are thick, some skulls will have, different tortuosity of the vessel. So based on all the literature searches we've done, we can comfortably treat 70 to 80% of patients, whereas you have the 10% of patients with thick skulls. If I can't find the clot with TCD, we're not going to treat it. So the first part of our automation is TCD looks for the clot. And then if it can't find it, you abort. So 10% of patients have thick skulls, and then another 20% might have some weird anatomy that, we're trying to go with under promise, over deliver. So let's say comfortably we feel we can treat 70%. Our first prototype was tested in March 2022. And it was great to see the first prototype actually work, right? Before that, it's all, you're testing theory. And then first test works, then you have challenges, right? How to modify different lengths, how to penetrate bone, different thicknesses of human skulls. And then we had to migrate now to animal models, trying to choose the correct animal model. So we had two Q pre-subs, and thankfully we did all of our testing with Jacobs Institute in Buffalo. And now we've gotten the response that is, okay, you can break up the problem into multiple tests, because there's no animal that has the same thickness as a human, skull thickness as a human, with the same distance to the middle cerebral artery, and the same diameter of the middle cerebral artery, even non-human primates like monkeys and gorillas. So we now are breaking up the problem into, targeting, showing that targeting efficacy works. And then for the safety part of it, we're going to be using swine model, brachial swine model, and then to prove the safety through the brain pathway, right? Because all of the action occurs at the focal point. No damage occurs on the pathway. And we've tested this with muscle, like pork tenderloin, showing there's no heat spots, no damage to the cells. And the next step we're actually doing is we're going to do it with a pediatric swine model. So once we show that all the actions occurring only at the focal point, they would, bless us to do our first in man. We raised $4 million from friends and family, 30 neurointerventionists, neurosurgeons, neurologists across the country. And we basically have done our animal work. We've gone to version 3.0 now, integrated the transcranial Doppler, the interface, and we've completed animal work in pigs. We've treated pig carotid vessels with 1 centimeter clots, 3 millimeter wide, and been able to completely recanalize. So now the next step is, coming to raise institutional funding to get everything lined up for our first in man study. From our standpoint, this technology can easily pivot to other diseases. So we could use it, for example, to modify the blood-brain barrier to allow intraarterial chemo to affect tumors. We can use it to liquefy clots and intracerebral hemorrhage so that your body drains them faster. If you have an intraventricular hemorrhage, that blood just stays there. And a lot of people die from this disease. But if I could hit it, liquefy it, your body naturally would recirculate the CSF and get rid of that blood. We can use it for pulmonary embolism, DVTs. So, and these we believe are much easier because we're not having to go through the bone for pulmonary embolism or DVT. You're just going through the skin and muscle, which is much easier. So yeah, we're excited because there's a lot of application for this. Obviously, I'm passionate about stroke. Being the immediate past president of SVIN, our goal was to double every 2 years the access to stroke therapies around the world. Most people in this space would know how big stroke is and how big of a problem it is. So one of the SVIN initiatives was called, it was the empty glass paper. It was published in Circulation, one of the biggest AHA journals. And what we showed is around the world there's a 2.7% access score, mechanical thrombectomy access score. Now in the US, it's probably 30%, which means 30% of Americans have access within a certain time frame to get appropriate treatment for stroke. That's still only 30%. 70% of patients don't have that access. So that's a lot, considering we're 330 million. For the rest of the world, it's about 2.7 million. So just imagine how impactful this could be by democratizing stroke care, by putting this in all hospitals. And what I envision, and when you said what's coming in the horizon, what I'd love to see is after we've pushed this technology into all comprehensive centers and all primary stroke centers, getting it to not only low-income, very low-income countries, but just getting it around the world, but getting it to ambulances. If you could go with the system and like a mobile stroke unit comes to your house, and then uses the machine to diagnose, oh, there's a large vessel occlusion, and hits you there with this histotripsy, recanalizes you, takes you to the closest primary stroke center. You don't understand how much, how significant the difference in outcomes would be. Like today, 60% of mechanical thrombectomy patients are fully functional. If you don't get mechanical thrombectomy, it's around 20-30%, meaning 70 to 80% of patients are disabled. So if we could move that 20% to 60% across the board, that would be huge, right? You have just people going back to work, plumbers going back to work, mothers taking care of their families again, right? It's just, it makes a huge difference. And I think that's what I would love to see.